So pregnancy, okay? So I start off with this thing. This is Melissa Williamson. This is back in 2004. Melissa Williamson, what's it?
Real.
This is real. Oh yeah, this is too stupid to make up. Melissa Williamson, 35 years old, of Bullitt Avenue, a resident, worries about the effect of her unborn child from the sound of those awful jackhammers across the street. Just all I'm saying is be careful before you call the media. I don't even know why the media took this picture and put it up there. You would think that there was a lot of checks and balances. I don't know if this is good to put up there. But now I feel bad for the child who's going to come out and say, oh, you were in the newspaper. So just be careful. Just know 5 steps ahead of what you're going to do. Yeah. And there's no, right now there's, yeah. And that's a real cigarette. This is back in 2004. They didn't have those, what do you call those, vapor things? And right now, I don't think there's any correlation between birth defects and the vapor thing. Not that I'm encouraging that, we just don't know. I would say to people, don't introduce anything into your body for 9 months. You know, you just don't know what's going on, all right? I think you could hold off with alcohol and smoking for 9 months, all right? I know, easier said than done because I'm a male. I understand that, but you want to have, you know, well, then the male should also say, look, honey, if you're doing that, I'll do the same thing too, right? Then you do it together, right? That kind of thing. All right, so anyway, this is what's happening over here. We got meiosis and mitosis. Now, this is old stuff for you guys. I'm going to do something on the board because I got to review it for you guys. But meiosis is really just to make a sperm. Meiosis is only to make an egg. That's it. That's the only purpose of meiosis. Okay, is to make an egg and make a sperm. Once the egg and sperm unite, you got fertilization, and now it becomes one. And from here on out, this is going to go through 1 cell into 2 cells, to 4 cells, to 8 cells, 16, and so forth until you get this. So the only purpose of meiosis is to make an egg and a sperm. Everything after that is just mitosis, mitosis, mitosis. Let me show you what meiosis is all about as a quick review, because these are questions that can appear on your exams. Okay? The best way that I could explain what this is to think of, instead of 46 pairs of chromosomes, think of 46 pairs of shoes. Okay? Now, who here has 46 pairs of shoes? You do?
Oh, I probably have like 100.
So 100 pairs of shoes. Anybody have more than 100 pairs of shoes? 150, 200. I actually did this survey for the past 8 years, and one person actually said that she had 372 pairs of shoes.
And the time to count them all.
Yeah. I mean, I got 500 ties, but they're easier to store, okay? They're on hangers and stuff. But 372 pairs of shoes. I know I sound bad with the ties, but yes, 370. I'm like, geez. But let me just show you. Now, I'm not going to draw 46 pairs of shoes. I think the easiest way that I could show you is just to show you 2 pairs of shoes and show you what's going on with this. So here you've got 1 pair of shoes, and these X's represent shoelaces, okay? And then we have another pair of green shoes with its shoelaces. So what we have over here is 46 pairs of shoes that are represented by 2 pairs. Does that make sense? Okay? What's going to happen is that we're going to split. So that you're going to have a pair of shoes here and a pair of shoes over here. Now, this division is called meiosis, okay? And it goes through the mitosis phases that you learned about in A&P1. It goes through prophase, metaphase, anaphase, telophase. We call this meiosis I, because we have another division we got to do. In the process of meiosis I, the 46 pairs of shoes has now turned to 2 cells where there's going to be 23 pairs here and 23 pairs here. Does that make sense? Okay? And we have something where the shoes are different. they did what we call crossing over. Green shoelaces on red shoelaces on green shoes. The DNA has crossed over and mixed. This is what is the reason why you don't look exactly like your brother or your sister. Then there's going to be another division over here. And you have this set up. And they go through the phases of prophase, metaphase, anaphase, telophase. We call this Meiosis II. Now, if we want to refer to metaphase in this duration, we call that Metaphase II. If you want to talk about prophase here, we call it Prophase I. Does that make sense? That's the nomenclature here. If it has the Roman numeral 1 on it, we're talking about during this division. If it has the Roman numeral 2 over there, it's this division. And when you get into your reading of your literature, of your textbook, they're going to refer to that, and that's what it's going to. Now, 46 pairs over here, now you got 23 pairs over here, now you got 23 shoes over here. There's no more pairs. We got half the number of chromosomes we started with. What do we call that, where it's half the number? Haploid. Good. And each one of these cells is totally different from the ones next to it. Look, this is a red right shoe with a green shoelace. This is a left red shoe with a green shoelace. This is a right green shoe with, you get the picture, right? I can't go through it, all right? But each one of them is totally different. We can add a tail to it. So you get 4 sperm. See it? All right? So that's where it goes on. It splits into 2. That's meiosis I, and then it splits again until you get 4 different cells over here with 23 chromosomes. Okay?
Meiosis consists of 2 consecutive nuclear divisions per round of DNA replication. The 2, called Meiosis I and Meiosis II, result in 4 haploid nuclei. A key difference between meiosis and mitosis comes very early in the first prophase. Mitotic chromosomes are independent of one another. But in Prophase I of meiosis, homologous chromosomes synapse. They pair up tightly. This diploid nucleus has 2 pairs of homologous chromosomes, n equals 2 and 2n equals 4. Note that the pairs have synapsed. During Prophase I, there is genetic exchange, crossing over, between chromosomes. Chiasmata are visible evidence of crossing over. Prometaphase begins as the nuclear envelope disappears and the spindle invades the nuclear space. Pairs of homologous chromosomes move together to the equatorial plate for Metaphase I. Now comes the second key difference between mitosis and meiosis I. In Anaphase of Mitosis, the chromatids separate. In Anaphase I of Meiosis, the homologous chromosomes separate. The chromosomes moving to the poles in Anaphase I consist of 2 chromatids each. This step reduces the chromosome number from diploid to haploid. Following Telophase I, there may be an interphase called Interkinesis. The third key point about meiosis is that there is no S phase, no DNA replication in interkinesis. The second meiotic division, Meiosis II, looks very much like mitosis of a haploid cell. The only significant difference is that, because of crossing over in Prophase I, the chromatids differ genetically. In Anaphase II, the chromatids finally separate. Remember that they stayed together in Anaphase I. At the end of meiosis, we have 4 nuclei, each with half the chromosome number of the original nucleus. Each differs genetically from the others.
Now, this can go wrong. Let me just show you something here. Here's the egg, and here's the sperm. Now, there's going to be 23 chromosomes in here and 23 chromosomes in here, right? To make an egg, it has to go through here. To make a sperm, it has to go through here. You have 23 chromosomes here. Now, I'm just going to represent 23 chromosomes by just one line, all right? You'll see what I'm drawing. And in this one, there's 23 over here. So when this unites, we now have a full set of 46 chromosomes. Now, to make this is meiosis. To make this is meiosis. When they merge, it's called fertilization. Now, once it merges, this is now called a zygote, and we'll talk about that. Now that's going to split into two identical cells. This is called mitosis. This will then split into two more. And again, these daughter cells are going to look exactly like the parent cell. And they will have 46 chromosomes in each one of them. That's all mitosis. Well, what happens when we have something that goes wrong? We have something called nondisjunction. Nondisjunction is if in meiosis that the split doesn't work properly. In other words, in meiosis I over here, it splits properly, no problem. This one splits properly, but this one doesn't. There's going to be both chromosomes that goes in one cell and nothing over here. You have an extra set of a chromosome in one of these cells. The first time over here, non-disjunction occurs, and it happens over here. So you're going to have a double set here and nothing over here. So you're going to have an extra set of a particular chromosome in either one of these for non-disjunction. So now when this comes together, you will have 3 sets of one chromosome there. Let's say the extra set, and we call this trisomy, when there's 3 in here. If it happens to be an extra set of chromosome number 21, we call it trisomy 21, or better known as Down syndrome. If it happens to chromosome number 18, we call it Edwards syndrome. Okay? Patel syndrome is chromosome 13. So it's trisomy 13, trisomy 18, trisomy. And trisomy is the #1 cause of miscarriages. That's the reason why, most common reason why a woman has a miscarriage is because there's trisomy. I know it sounds bad, but it's Mother Nature's way of saying it's going to be a bad pregnancy. Let's get rid of it. And that's what it does. Okay? I kind of tell the parent, because you have to understand, when you go through this, I've seen many women with miscarriages. It's just in my field. But I got to also think that that woman's that's her first miscarriage. So you got to have that compassion over there. And it's the truth. What I tell her is that there's nothing that she could have done to prevent this. There's nothing that she's done to cause this. It's just this particular time, God bless you, this particular time, it's just his and your chromosomes didn't mix in a proper way. It does not mean that the next pregnancy is going to be in this situation. They may mix properly. And it's the truth. It's just, I have to talk about it in layman terminology. Okay? So, trisomy is when there's 3 versions of one chromosome. And this is due to what we call non-disjunction. All right? Most trisomies, as I mentioned, is incompatible life, and most common cause, MCC, most common cause of miscarriages for the first trimester is miscarriages. All right? So some may survive, but a lot of them will die at an earlier age. Trisomy 21, we've talked about that briefly, all right? That's an extra chromosome number 21. There's many features, including mental status, right? A decrease in mental status. But there's other things that go, it's a syndrome, so it's not just one thing, it's a battery of things. Maybe there's something wrong with the heart, there's something wrong with the hand, So if there's something that in trisomy 21 where there's so much, because even trisomy 21, a lot of them turn into miscarriages. But there's so much there, it'll turn into miscarriage. But there's some that it's, the heart is not as bad as what some others would be, then it will be able to survive. There's the trisomy 18 and 13. I won't ask you about these, but you should have an idea what trisomy is in conjunction to non-disjunction. Okay? Questions about that? All right, now, as I showed you over here, you're going to have the split up for sperm. In spermatogenesis, making of the sperm, from one cell, you're going to get 4 functioning sperm. You see, 4 functioning sperm. From this one cell over here, you will get 4 functioning sperm. Hint, hint. Understand the word functioning. Okay? That's different than what we do with females. In oogenesis, we have a different thing that goes on. You women are more complicated than I could ever imagine. But that's why I wanted to go into the field, because I'm still trying to learn from you. All right? But you probably know this stuff better than me. All right? But it's a little bit more complicated. In oogenesis, the development of the egg, what happens here is before birth, you have all the mitosis happening. You have all these eggs before birth. 4 million, that's it. The mitosis takes place inside. So to make one of these is mitosis. From here on out, it's going to be meiosis. To make this oogonia, it's called. You're born with a certain amount of eggs. 4 million. Okay? Men keep on producing more sperm. They're always producing more of this, what we call spermatogonia up here. But women, you're born with a certain amount, and that's it. Then, at puberty, meiosis begins at meiosis I and then stops at metaphase II. So this is what happens. Here you're going to have this egg that's going to split into 2. All right, which is basically this layer here. Splits into 2, the first division. But look what's happening here. They don't split up equally. It's not a 50-50, the cytoplasm goes in 50-50. It's more like 99-1%. The chromosomes are going to be split, but the cytoplasm is different. In this case, you're going to have one that's going to have very little cytoplasm and one that's going to have tons of cytoplasm. Why is it set up like that? Why would you want to have one having tons of cytoplasm in it?
That to sustain the fertilized product?
Well, you're both on the right track. What's going to go inside here? Sperm. So if it goes in with only 50% of cytoplasm, there isn't much of the process to take place. So you're going to need a lot more cytoplasm for that to happen. You need a bigger pool, so to say, to put something else in there. So it splits off. Now, this part over here is called a polar body, also known as a Barr body. Barr is a capital B-A-R-R. So you'll see it both ways. This polar body or Barr body is useless. They don't use it. It needs to be made so that we can have, the haploid situation going on in the one that we're going to use. So this is going to split, and then it's going to start meiosis II, but it stops at metaphase II. And it stays like that. All right? It doesn't fully develop. All right? Now, what's going to happen over here is it depends on if the egg gets fertilized or not. Depends on if the sperm goes inside this egg or not. If the sperm goes inside the egg, then it's going to finish meiosis II. So meiosis II is then completed. And when it does, it's going to split. We're going to have a lot of cytoplasm 1, and then here's your second Barr body. okay, or polar body. This one may or may not split, all right? This one may or may not occur. But that's where you get 1, 2, 3, 4, as much as you see the 4 over there. This is the one we're concerned about. So what happens here is that in males, you get 4 functioning sperm. In females, you get 1 functioning egg with 2 or 3 Barr bodies. In most cases, you're not going to fertilize every month. So what happens here is that if fertilization does not occur, then this egg goes out with the menstruation in the phase of Metaphase II. Never finished Meiosis II. For it to finish Meiosis II, it has to be fertilized. So it just goes out with the menses in Metaphase II phase. Okay? Makes sense? You're a little bit more complicated. But you need to understand polar bodies, Barr bodies, and all this stuff for you to understand your lecture material. Okay? Questions on that?